Hi guys. So we'll be starting in 1 minute or two. I hope you guys are online and attending the webinar. Whoever posted doubts, please be online. I'll be answering your doubts one after the other. So guys, I will be taking the doubts from the Facebook comments that you have posted on the post. So there will be no questions that will be taken through the chat. The chat section is disabled. So kindly post your question in the comment section. I have that open. So I'll take doubts from there. Okay, then let me start. So first question has been posted by Jitendra Maurya. 1 minute. So let me see the first question. Hmm. The question is a single phase VSI shown in the figure is feeding power to a load. Triggering pulses of the devices are also shown in the figure. If the load current is sinusoidal and 0 at 0 pi 2 pi, A naught has the waveform. Okay. So load current is basically sinusoidal and it will be sine t because it is 0 at pi 2 pi 0 and all those things. So I can say IT is basically okay. Then it is saying the duty cycle or the switching pattern is given to us. First one is for S1 and S2. I think S1 and S4. Other is for S2 and S3. Okay. Now see, since the load current is sinusoidal, let us see how the switches will conduct. So from 0 to pi by 6, none of the switches is on, but the current must be positive. So if the current is positive, which devices should conduct? Let me say diode D1 is parallel to S1, S2 D2, S3 D3, and S4 D4. Okay. So if S1 and S4 are not conducting, but still the current is positive, that means from 0 to pi by 6, the diodes that are conducting are D2 and D3. Because both S1 and S4 and D2, D3, they carry the current in same direction. That is, the current is positive. Then from pi by 6 to pi by 3, as you can see, we have the switches S1 and S4 conducting. So up to pi by 3, S1 and S4 will conduct. So what we can say is 0 to pi by 6, D2 and D3, pi by 6 to pi by 3, S1 and S4. How I am saying this? I am saying this based on the direction of current and the switching pattern that is given to me. Then from pi by 3 to 2 pi by 3, it is 2 pi by 3. So again, as you can see, there is no switch that is conducting. So for positive current flow, diodes will have to conduct. Then 2 pi by 3 to 5 pi by 6. Again, the switches come into conduction. So S1, S4. Then again 5 pi by 6 to pi. Again, diodes will conduct because none of the switch is conducting and still the current is positive up to pi. Then in the negative half cycle, same thing you have to repeat, like from pi to 7 pi by 6. Since the switches are not conducting, diodes will have to conduct. Otherwise, the current would be 0. But as we can see, current is non-zero. So here, which diodes will conduct? D1 and D4. Why? 4 and switches S2, S3 both carry negative current. So for negative current, either D1, D4 must conduct or S2, S3. So that way you can figure out the switching pattern. Now it is asking me the voltage of VA naught. So VA naught pattern we have to draw. So now if you see, we have two capacitors placed in parallel to VDC. So this is the circuit that is given to me. So both the capacitors will have voltage of VDC by 2, again VDC by 2. They both will have this much voltage. Now here we have switches and diodes. Like this, we have switches and diodes. So this is S1 D1, S4 D4, S2 D2, then S3 D3. Now this is point A. Now whenever, this is basically O. So whenever S1 is on, VAO is VDC by 2, either S1 or D1. Whenever either D2 or S2 is on, the voltage can be taken through the lower capacitor. It will be minus VDC by 2. Now previously I have told you how you can figure out which device is conducting in what interval. And once we know which device is conducting, we can figure out VAO. Like I told you, from 0 to how much time? 0 to pi by 6, the diode D2 and D3 were conducting. If D2 is conducting, it will be minus VDC by 2. Then from pi by 6 to pi by 3, S1 was conducting, so plus VDC by 2. Then again diode was conducting, minus VDC by 2. Then again switch, plus VDC by 2. Then again diode, minus. Then from pi to 7 pi by 6, what I told you earlier was, from pi to 7 pi by 6, D1 and D4. And now as I've shown you, whenever D1 conduct, plus pi by plus VDC by 2. So that way waveform will go like this. Okay, that will be VA naught versus time. Moving forward, moving to the next question. Again, Jitendra Maurya has posted from Power Electronics. So let the question become a clear. Okay. Assuming a linear fall of voltage across a transistor at turn on, falling from V to 0 in a time t1, if the expression for snubber inductance L, which delay the rise of current to its on state value of I in a time t1. 1 minute. The expression for the snubber inductance L, which will delay the rise of current to its on state value I in a time of t1. Okay. So it is saying we need to find the snubber inductance such that the rise of current from 0 to I is delayed so that it happens in a time t1. Okay. So this is fine. So the voltage. First of all, let me write the voltage equation. Voltage equation is V is equal to V 1 minus T by T1. Now, once I have this voltage equation, what I shall do is, this voltage equation or this voltage shall be equal to the inductor voltage, that is L di by dt is V 1 minus T by T1. Okay. So what it says is di is equal to V by L 1 minus T by T1 dt. Now it says that the current increases to I in a time of T1. Sorry, di V by L 1 minus T by T1 dt from 0 to T1. So what I am saying is the current through the inductor is increasing from 0 to I in a span of 0 to T1. So it will be I is equal to V by L, then T1 minus T1 square by 2 T1, that is T1 by 2. So V T1 by 2L. So which means L is equal to V T1 by 2I. Okay. So that should be the value of 1 minute. Have I missed something? Okay. Actually, this is T2. I wasn't reading clearly. This is T2. So this is T2 square by 2T1. Okay. Sorry, T1 square by 2T2. So now what can we do here? It is saying a linear fall of voltage across transistor at turn on, falling from 0 to V to 0 in a time of T2. I think the question is not actually clear. The expression for snubber inductance L, which will delay the rise of current to its on-state value I in a time of T1. So voltage is falling linearly. So this will be the voltage equation. So the current must go from 0 to I in a time of T1, where T1 is actually given to us as less than T2. After that, the current becomes constant. So what we can do differently here is the current should rise to I in a time of T1. Hmm. So what I am assuming here is the entire voltage appears across linear fall of voltage across the transistor. Oh, 1 minute. So this is basically transistor voltage. So let me do it again. So this is basically transistor voltage, not the inductor voltage. So what will happen is inductor voltage will be supply voltage minus transistor voltage, that is Vt by T2. Now this will be L di by dt is Vt by T2. So di will be V by L T2 into T dt. Now when you integrate it from 0 to I, it will be V by L T2 integral T dt from 0 to T1, because current increases from 0 to I in 0 to T1. So I will be equal to V T1 square by 2T2 into L, which means L is equal to V T1 square by 2I T2. So that will be the value of snubber inductance L. Okay. So you have to take care that the voltage given here is the voltage across the transistor. So supply minus transistor voltage will give me the voltage across the inductor. The next question is again from Jitendra Maurya. A three-phase winding transformer have primary, secondary, and tertiary turn 100, 50, and 40. Rated primary voltage 400 volt, and that of voltage primary draws a magnetizing current of 1 ampere. If secondary delivers a current of 4 minus 4J, the capacitance to be connected in tertiary to improve the primary power factor to unity. Okay. So what you have to do here is you have to refer everything to primary first of all. Okay. So it is saying secondary delivers a load current of 4 minus 4J. So what will be the primary current what will be the primary current based on secondary current? 4 minus 4J into secondary number of turns. Secondary turns are 50. Primary turns are 100. That is 2 minus 2J. So that will be the reference of the secondary current into the primary winding. Now it is saying it is drawing a magnetizing current of 1 ampere. The value of capacitance to be connected in tertiary to improve the power factor to unity. So suppose I capacitor primary is basically equal to 400 by minus jxc. That is J 400 by xc. So what I am doing is I am assuming that the capacitance is referred to primary. So the current that it will draw is voltage by its impedance. Because what happens when you refer the entire thing to primary, this will be your magnetizing reactance. Okay. This will be your capacitance. And this will be your secondary current that is drawn by the secondary winding. So what will be the magnetizing current? Since magnetizing current is flowing in an inductor, it will lag the voltage by 90 degree. So 1 minute. I am assuming voltage as reference. Magnetizing current is 1 ampere. So it will be 1 angle minus 90. Then what about the secondary current? It is 2 minus 2j. Now we know that it should have a power factor of unity, that is, if you add all the currents, minus j, that is magnetizing current, plus j 400 by xc, then plus 2 minus 2j. This should be purely real. Why? Because when current is real, the power factor should be unity. So we have to equate the imaginary part to 0. What is the imaginary part? Minus 1 minus 2 plus 400 by xc. It should be 0, which means xc should be equal to 400 by 3, that is 133.33 ohm. Once I have xc, I will refer it to tertiary winding. So if you want to refer it to tertiary winding, 40 square by 100 square into 133.33. Okay. Once you get this value, capacitance will be equal to 1 by 2 pi f xc dash. That will be the required value of capacitance. Okay. So what I have done is I have taken all the currents to primary, and then what I am saying is the total value should come out to be purely real in order for the power factor to be unity. The next question is again from Jitendra Maurya, Power Electronics. So Jitendra, what happened is during the on state, in this question what I feel is during the on state, you have to figure out the voltage across the inductor. It is just applying the volt second balance. So this is the inductor. So the voltage across the inductor, if you figure out from 0 to t on, the inductor voltage is given to me as 200 volt, and from t on to t off or t on to total time, the inductor voltage should be minus 250. This is how I am deriving this voltages. As you have given to me just the solution, so from the solution you can see that this is the voltage across the inductor. So this you have equated L di by dt is 200. Here L di by dt is minus 250. Since the voltage across the inductor is constant, the current should be ramp. Is operating on the edge of discontinuity or discontinuous conduction. That is why the minimum current has to be equated to 0. That is, it is starting and ending at 0 because it is operating on boundary of continuous and discontinuous conduction. Okay. So once we have drawn this triangle, what he is saying is this is the on time dt, this is the total time t. Then he is just applying the concept of geometry. This is A, B, C, D. So what he is saying is BC. Basically, the height of the triangle is equal to base multiplied by tan theta. Tan theta is nothing but the slope. Okay. Then in BCD, BC by CD is also the slope, which is equal to 250 by L. That is delta y by delta x, which means BC is again 250 by L. That means into CD. CD is how much? T minus dt. Now you can equate BC from both the triangles in order to find out dt. And what he is doing now, 1 by 2t. So dt he has determined. So what we know is dt, then 1 by 2 t dt into bc. I think he is trying to figure out the average switch current. So average switch current is nothing but L half into dt into bc by total time, that is t. Because this is the inductor current, this current shall flow through the switch only for 0 to dt. So this will be the waveform of the switch current. Okay. So if you want to find out average area upon the total time, that is what he is doing. But I think you asked this question on the group before and your solution was correct. So you need not worry about what kind of solution is followed in the book. Next is again from Jitendra Maurya. In a three-phase AC machine, EMF is E1. Output is P1 for a phase spread of 60, whereas EMF is E2 and output is P2 for a phase spread of 120. See, EMF in a machine is given by 4.44 Fn phi into Kd. I am not considering Kp because it does not depend on the phase spread. Now, what is Kd? Sine m beta by 2 by m sine beta by 2. M is the number of slots per pole per phase. Beta is basically slot pitch. Okay. So now M beta is basically called as phase spread. Okay. So now when you want to find out the ratio of EMF, you have to see the number of turns per phase. Since the phase is kept same, only a three-phase machine. So EMF1 by EMF2 is nothing but KD1 by KD2. Okay. Now how to find out the 2 KD? Beta always remains the same, only M will change. So in one case, beta by 2 is 60 degree and M2 beta by 2 is 30, which means M1 by M2, if you take the ratio, is half. Now KD1 by KD2 will be sine M1 beta by 2 by M1 into M2 by sine M2 beta by 2. Okay, sine beta by 2 will get cancelled because beta remains the same. So it will come out to be how much? So how much will it come out to be? Sine 60 by 2 by sine 120 by 2, and M2 by M1 will be 2 because M1 was by M2 was half. So sine 30 upon sine 60 into 2. Now when you talk about power, power is nothing but it is 3 E phase I phase. I phase always remains the same, so only E phase changes. So power 1 by power 2, since the number of phases are again kept same, that is 3 phase, so it will be equal to E1 by E2. So that power ratio will be same. Okay. The next question is from Naveen Kumar. Naveen, actually this common collector question, I'll have to check it over the net. I'm not so much well versed with the concepts of this feedback. So you can tag me in the post. You post one question and I'll reply there. I'm moving on to the next question. Next is again from Naveen Kumar. If one multiplexer and one inverter are allowed to be used to implement any n variable function, so how much multiplexer you will use? See, for any n variable function, if you have mux plus inverter, then you only need 2 to the power n minus 1 is to 1. But if you only have mux, then you need 2 to the power n is to 1 mux. So remember this general rule. If you have inverter, you require one less line. If you don't have inverter, you require one more line. Next is again from Naveen Kumar. The incandescent bulbs rated respectively as P1 and P2 for a specified operation mains are connected in series across the mains. And the power supplied by the mains to the two bulbs is, see, if power is given at a specified voltage, so resistance can be figured out as V square by P1 and resistance of 2 will be V square by P2. If current was specified, then power that I will use will be I square R. If voltage is specified, V square by R. In series, resistance will be R1 plus R2, that is V square 1 by P1 plus 1 by P2, that is V square P1 plus P2 by P1 P2. Now overall power will be V square by R, which is P1 P2 by P1 plus P2. So that will be the answer. That is option A. So you are right that it should be option A. Next again from Naveen Kumar. A three-phase 33 by 6.6 kV delta star transformer is protected by a differential protection scheme. The CT on 6.6 kV side has a ratio of 100:1. The ratio on 33 kV side. To form a table like this. So here we have delta. Here we have star. So what shall be configuration of CT? Here we will have star delta. Then here we have 33 kV line voltage. Here we have 6.6 kV line voltage. So what about line current? So line current, if it is I here, so how much will it be here? So as we know, VI should remain same. So 33 into I should be 6.6 into I2, which means I2 is equal to 5I. Because power should remain same on both the sides, that is VI should remain same. Okay. So now we have line current. This line current is basically the primary current of CT. So the CT ratio here is 100:1. So what is I secondary? I secondary is 5I by 100. This is basically the phase current. So what about line current of current transformer? Since the current transformers are delta connected, 5I by 100. I will assume here that the transformers are K:1 transformer, CT. Now I know IL. Now once I know IL, this is basically primary current of CT. What about secondary current? Since the ratio is assumed to be K:1, it will be I by K. Now we know the current transformer are star connected, so the line current will be same as phase current, that is I by K. Now under normal condition, these two currents should be same so that differential transformer does not operate. That is I by K should be equal to 5 root 3I by 100, which means K should be equal to 20 upon root 3. Okay, that is 20 is to root 3 transformer I need. The answer will be C. Is it fine? If you form a table like this and solve every question, you will always get the correct answer. Next is again by Naveen. If a certain op amp has a closed loop gain of 20 and upper critical frequency of 10 megahertz, then the gain bandwidth product is closed loop gain of 20 and upper critical frequency is 10 megahertz. It should be 20 megahertz gain bandwidth product. Why? Because in case of upper critical frequency, if I assume a symmetric characteristic, upper critical frequency is this much. So this itself will be counted as the bandwidth. So bandwidth is 10 kilohertz. So 20 into 10, it should be 200 kilohertz. Okay. So I think this should be the answer. That is, sorry, 200 megahertz. 20 into 10 simply. So kindly let me know what is the answer given. Based on that, we can discuss more upon it. The next question is again from Naveen Kumar. Which network theorems are applicable to both linear and non-linear elements? So basically, what network theorems we study? Superposition. Superposition is only applicable to linear. Okay. Then what about the next theorem, that is Thevenin's theorem? It is again for linear. Same is the case for Norton. Only linear elements. Then what about maximum power transfer? That is again for linear. What about Telegen's theorem? Telegen's theorem can be applied to linear as well as non-linear. Reciprocity again for linear. So I guess the most important theorem that is applicable for linear as well as non-linear is your Teligens's theorem. The next question is from Karthi. A DC chopper is used for separate regenerative braking of a separately excited DC motor. The DC supply voltage is 400 volt. Motor has armature resistance 0.2 ohm. Then Km, that is the motor constant, is 1.2 volt second per radian. The average armature current during regenerative braking is kept constant at 300 ampere with negligible ripple. For a duty cycle of 0.55 for a chopper, power returned to the supply is. So whenever you use a chopper for regenerative braking, basically it is a boost converter. Okay. So what happens in boost converter is the motor is connected at the load. Now it is acting as a supply. Now we know the current is 300 ampere. We know Km, we know armature resistance. So we know DC supply voltage is 400 volt. What about the terminal voltage? For terminal voltage, we need what we need? We need EMF. Now we have IA, we have Km, we have RA, we have duty cycle. So what I'll do is we will find V naught. V naught is Vs by 1 minus D. So how much will it come out to be? 400 by 0.45. Okay. Now once we have V naught is basically EMF plus IA into RA. Okay. Now once you have EMF plus IA into RA, we can find out EMF. Okay. So what is the power returned to the supply? What I feel is if we directly multiply VT into IA, what is VT? 400 by 0.45. So power returned to supply is simply V naught into IA. That will be the power returned to the supply. Okay. And power generated by the machine will be E into IA. That is the power that will be generated by the machine, and this will be the power that is returned to the supply. V naught you can find out as a output of boost converter. Okay. So that will be the output. Next question is from Rahul Patnaik. Why are transformers stamping any yield before being used for the building? Okay. So the options that he is giving me to me is to reduce the eddy current loss due to burning of the edges, and the next is to reduce hysteresis loss due to burning of the edges, and the next is to give mechanical strength, and the last is to increase core permeability. Okay. So 1 minute. Just Naveen commented on a previous question that the gain bandwidth product is given as both A and C, 200 megahertz and unity gain frequency. So see, what he's saying is, if the gain is unity, then the frequency will itself be 200 megahertz. Why? Because gain into bandwidth shall remain constant. So gain bandwidth product will also be equal to unity gain frequency as well as 200 megahertz. Okay. Now coming back to the question that I was discussing, transformer stamping annealing. Okay. So basically transformer stampings are annealed uh, in order to reduce eddy current loss. So actually the transformer stampings are annealed in order to increase the core permeability or in order to give the desirable characteristics to the core. So Rahul, the correct answer should be 4, that is to increase the core permeability. Loading of a cable is done in order to increase its inductance, increase its leakage resistance, decrease its capacitance, achieve distortionless condition. So Naveen, in case you want to achieve distortionless condition, RC should be equal to LG. Okay. So that is the condition for distortionless transmission. I don't think it has anything to do with the loading. So that means I feel the answer should be only 1. It should not be 4. Okay. So answer should be only 4. Oh, only 1. The next is again from Rahul Patnaik. A three-phase induction motor is driving full load torque which is independent of speed. If line voltage drops to 90% of the rated value, percentage increase in the motor copper losses. Okay. Is driving a full load torque which is independent of the speed. That is, the torque is constant. It does not vary with the speed. So torque is independent of the slip. So what happens if line voltage drops to 90%? Then we know if torque is constant, then SV square should be constant. So once we know that voltage is dropping to 90%, then we can find out slip. Slip into S1 into V square should be equal to S2 into 0.9 V square. That is S2 is equal to S1 upon 0.81. Now we know the new slip. So once we know the new slip, what we can find out is increase in motor copper losses. Now copper losses are nothing but S into Pg. Okay. Now when we know that the air gap power shall remain constant, so what we'll do is it will become PCU2 by PCU1, or you can go by one other method. The torque is constant, so mechanical output, that is torque into speed, okay, which is T into omega s 1 minus s. So you can find out PM2 by PM1, it will be equal to 1 minus S2 by 1 minus S1. Now we know PCU is equal to S upon 1 minus S into PM. So PCU2 by PCU1 is S2 by 1 minus S2 into S1 by 1 minus S1, sorry, into 1 minus S1 by S1 into PM2 by PM1, but that is 1 minus S2 by 1 minus S1. So that is S2 by S1. Now S2 we saw it is 1 by 0.81 S1. So it will be 1 by 0.81. So I think it will be around 1 by 0.81. So it will be around 19 or 18%, that you can check. So 1 by 0.81, you can find out the value and you will know the answer. So how much shall it come out? 100 by 81, 1, then 190, that is 2, 162, 38, 28, 280, 280. So it will be 3. So it will be around 23% increase. That is option A. So remember, whenever load torque is constant, SV square remains constant. The next question is again from Rahul Patnaik. The speed of an induction motor is kept controlled by varying V by F frequency by keeping V by F constant. Breakdown torque and magnetizing current both would remain constant. Breakdown torque will remain constant, but magnetizing current would increase. See, breakdown torque is the maximum torque, which is 3 by omega s, 3 by omega s into V square by 2x2. Now, omega s is directly proportional to frequency, x is directly proportional to frequency, which means maximum torque is directly proportional to V by F square, which is constant. Okay. So breakdown torque remains constant. Now V by F is directly proportional to flux. Since flux is constant, the magnetizing current I mu shall also remain constant. So the answer should be both should remain constant. That is A. The voltage stress will be maximum in an underground cable at the surface of the conductor. Remember this, in a conductor, the electric field or the stress is maximum at the surface. So inside the conductor, electric field is zero. So at the surface, it is maximum. Then it decreases hyperbolically. So this is at R. This is at capital R. Okay. Here it will be Q by 4 pi epsilon naught R. That is the maximum electric field or electric stress. Next is again from Rahul Patnaik. When two identical first order systems have been cascaded non-interactively, the unit step response will be non-interactively. Basically means there is no loading effect. That is, there is no current flowing between the first and the second system. So if you are cascading them, then we can directly multiply their transfer function. So this is the first system. This is the second system. Now, as you can see, there are two poles. Both are real and unequal. If both are real and unequal, that means the system is overdamped. So answer should be A. So next is Naveen. Relays that is sensitive to power swings. Actually, Naveen, both the relays, impedance and reactance relay are sensitive to power swing. Only more relay is not sensitive to power swing. So answer is both correct, A and B. Next is from Rahul Patnaik. A waveform shown is applied to the input of a applied across primary of a pulse transformer which has 1:1 turns ratio. The output on the secondary will be as shown. So what happens, Rahul, is we have the input applied across the primary. So this input, what it will do is we have a square wave pulse. So what happens is the flux that will be developed. Flux is basically integral of voltage. 1:1 turns ratio. Output on secondary side. So 1 minute, let me think about it. A waveform shown as input is applied across the primary of a pulse transformer which has 1:1 turns ratio. The output on secondary side. So we know that the input voltage is basically equal to the EMF because there is no voltage drop in between. This should be equal to minus N1 d phi by dt. Okay. Now we are saying 1:1 turns ratio. So let me call it as minus d phi by dt. So what should be the value of y? Then what should be the value of phi? See, there can be two cases. If this is your waveform, so assuming that it starts from 0 to certain V. If it is starting from 0 to certain V, then what happens? So what will happen is, it will have a non-zero DC value, that is V by 2. Now this DC value, or it can be also written as V by 2 plus sum as a Fourier series. N is equal to 1 to infinity. Bn sin n omega naught t. Now these sinusoidal components will be directly reflected across the secondary, and but this DC value will cause saturation of the transformer, due to which what shall happen is Due to this DC value will not be reflected across the transformer. Okay, that is, it will saturate the transformer. That is, the flux will become constant, and this constant flux derivative will be 0. So there will be no DC component induced across the secondary. So which means what will happen is, so what shall happen is, this AC terms, they will directly get reflected across the secondary, but DC cannot get reflected across the secondary. So what I feel is the answer should be actually D. There will be impulses across the secondary winding based on derivative of this. Okay, because here the pulse goes from 0 to positive, so positive impulse, negative impulse, positive impulse, negative impulse. I think waveform should be like this because DC cannot get induced across the secondary. Only AC can get transformed, and when we'll take AC, only we'll get the impulses sort of waveform, that is alternating waveform. We cannot have a DC value. Okay, that is, the waveform should be alternating in polarity. Next is again from Rahul Patnaik. Rahul, we need directional relays at the load end, but if you see here, there can be three such relays, 2, 3, and 5. So you must be knowing that we need non-directional relay at it is like this. In case of transmission line, that means all the sequence networks are mutually uncoupled. Okay, but that is so because in phase A, B, and C, we have always assumed the same self reactance Xs and the same mutual reactance between the two phases Xm. But if you vary it, in case of untransposed line, the inductances will not be same, which means So guys, I think the connection was lost. So let me continue from where we left off. So I was telling about question number 259 and 260. In question 259 by Naveen Kumar, corona loss can be reduced by the use of hollow conductor because current density is reduced. Yes, the answer will be current density is reduced. So what happens is for a given, what he is saying, for a given cross section area. So I think Naveen, the more appropriate will be C. Why? Because is if you want to keep current density constant, then for same current you have to keep area constant. But in hollow, the area is pi capital R, that is outer radius square minus inner radius square. And in solid, it is simply pi a square. Now if both are same, sorry, I is equal to constant, then what I mean to say, if current is same, current density is same, the area must also be same, which means R must be greater than A. So if radius is increased, the electric field, which is Q by 4 pi epsilon naught R, or in case of cylinder, it is rho by 2 pi epsilon naught R, will decrease. If electric field decreases, corona loss will reduce. Okay. So what we can say is current density will remain same, but electric field will reduce. In 260, the insulation of modern EHV lines is designed on the basis of it is the switching over voltage, and for low voltage line, it is the lightning over voltage. The next is from Rupesh Kumar. A unity feedback system has open loop transfer function 25 upon s plus 8. Now a derivative component having a transfer function s by 10 is introduced. What shall be the damping factor? So GS is basically 25 upon s into s plus 8. So now when you take a derivative factor that is into s by 10, so it will become 25 upon s plus 8. So what will be the transfer function overall? It will be 25 upon s plus 33. What I have done is gs over 1 by, sorry, gs over 1 plus gs. Now in this, it is asking the damping ratio. Now actually it becomes a first order system after introduction of unity feedback. You can find out the damping ratio. Rather, you can find out the time constant. What is the time constant? It is 1 by 33. Okay. So here there will be no damping constant or damping ratio that will be found out. Next is from Rupam Soni. If there are n elements in a network, then is it possible there are less than n elements in the dual of the network? Rupam, I don't think so it is possible, but what happens is, suppose if two elements are possible to be combined in the dual, then we will say that the elements will be reduced. Okay. Then again from Rupan Soni, consider the given network VC is equal to 4 minus 5 VB. Then what should be the value of X? So Rupam, let us study this network. This is 4 ampere. 1 by 3 ohm. Then 1 by 5 ohm. X. 1 ohm. 1 by 2. Okay. Now it is saying VC is 4 minus 5 VB. Okay. VC, VB. Sorry, VB and VC. So now what we can do is we need to find X. So 4 ampere current is given to us. So what you can do in 4 ampere is basically we have to apply nodal analysis here. So we will only assume two variables, VB and we will assume VA because VC is already known, that is 4 minus 5 VB. So now if you see VA, if we apply nodal here, incoming current is 4, the outgoing will be VA minus VB by 1 by 3, that is into 3, plus VA minus VC into 2, that is 3 VA minus 3 VB plus 2 VA minus 2 VC minus 2 VC will be minus 8 plus 10 VB. So 12 is equal to how much? 5 VA then plus 7 VB. This is first equation. In the second, what you can do is you can consider this as a super node. Okay. Then what will have the input current, or what we will have the outgoing current? VB minus VA into 3, then 2 into VC minus VA, then VC is equal to 0. That way we will have another equation. If you substitute VC in terms of VB, we will have two equation in two variable. You can find out VC and we can compare it with the given equation. So we can find out X. Okay. So that way we can find out our answer. So Rupam, what mistake you have committed is you have directly divided the 4 ampere current in the two resistances, 1 by 3 and 1 by 2. But for current division, the resistances must be parallel. And for parallel connection, both the terminals of the resistances must be connected together. Now, if you see the two terminals are connected at A, but the other terminal of 1 by 3 is at B and the other terminal of 1 by 2 is at C. So that means they are not connected in parallel. So do not apply blindly the current division. You please check whether or not the resistances are in parallel. So next is from Naveen Kumar. Compared to two winding transformer, auto transformer has copper losses. Copper losses are less because copper requirement is reduced in case of auto transformer. Leakage reactance is also less because two windings are wound on the same core. So it is also reduced. And for application of shaded pole motor, Naveen, such kind of questions you can Google it directly, because if there is some certain question that requires for me to solve it, then only it is beneficial for the entire community. Otherwise, you can Google it and you can find out the answer. So let me provide you with the link. So guys, if there is some theory questions directly, that is what is this, what is the application, what is the advantage, disadvantage. So you can just search it over the net. That will be more beneficial and more fast as compared to the option of asking on the group. Okay. So Naveen, you can check this out. The link that I have posted. And KTES shall be available from the month of June or July. Then we will be providing you with the logins, okay, so that you can start giving the test. But right now, KTES is not activated. Any other question, anyone? So I think I have answered all the questions that were posted right now. Okay. So guys, we'll see you in the next webinar that we'll conduct in the month of May. Till then, keep posting doubts in the group. And if your doubt is not answered, then do one thing. Then please tag me in that doubt. I'll be happy to answer, because sometimes I may miss some doubts because I might be busy with some other thing. So please do take care. Just tag me in the doubt. So Rahul, the question that you have posted is a previous year gate question. For checking out the solution, you can check out the previous year's question bank that we'll send it to you soon enough. The question bank is ready. Just we'll get it printed and we'll start dispatching it. Let us say in a span of 15 to 20 days or a month. Then you can check out the solutions of previous year gate questions. If there is certain question for which the solution is not already given, then I'll be happy to answer it. But we have answered such kind of questions in very much detail in our circular So one last question I'll answer for Rahul. Webinar was not closed. So Rahul, the thing is that whenever the brushes are on M and A, the voltage induced is maximum. So whenever the brushes are on A and B, the voltage will be maximum. Okay. Now once you have shifted the brushes to A dash and B dash, the voltage will not be maximum. So that means first thing that you have to do is, since the commutator is moving towards right, if I assume that the commutator is stationary, I can say with respect to commutator, the brushes are moving to the left. If brushes are moving to the left, then they will come from A dash B dash to AB. As soon as they come from A dash B dash to AB, the voltage will be maximum. That is, the voltage will increase from A dash B dash to AB. Now they will move away from AB, so voltage will again decrease. Then the same pattern will be repeated like this. So waveform will be like this. It will be more tilted towards the left. So the options that you have given me, the correct answer would be the option A. Okay. So here you have to consider the commutator as stationary and assume that the brushes are moving from right to left, and based on that plot the voltage. And remember, whenever brushes are on M and A, the voltage is maximum.